There has been many models that have been proposed by scientists about the structure of an atom. This tells us that scientists were and are interested to know what atoms look like. But why on earth would scientists want to know what atoms look like? Atoms are the building blocks of material. Everything that you see around you, including yourself, is made up of these small atoms. So, this tells us that knowing what atoms look like is important because it helps us to understand why materials have different properties and why some materials bond with other materials. For example, why does this pen look different from this Play-Doh? And why do they behave differently? To understand the properties of these different materials, we must first have an idea of what an atom looks like. And typically, when we talk about the structure of an atom, we use the Bohr model of an atom. So this was a model that was proposed by a scientist called Niels Bohr. Hence, we have the Bohr model of an atom. In this model, atoms are made up of a positively charged nucleus here at the center. That is the nucleus. And then they are surrounded by negatively charged electrons. So you see here we have 1, 2, 3 electrons. So let me just break this model down a little bit. In the center of an atom, according to the Bohr model of an atom, there is a nucleus. This nucleus is made up of positively charged protons and the electrically neutral neutrons. Hence, we would say the center is a positively charged nucleus. And orbiting this nucleus we find that they are negatively charged electrons. I have said to you that atoms are made up of a nucleus at the center and electrons orbiting around that nucleus. I've also mentioned that there by the nucleus, we found that the nucleus is made out of what we call neutrons as well as protons. So we have this now three subatomic particles: neutrons, protons, and electrons, which make up an atom. We need to study some of their qualities. We need to know some of their qualities, these three subatomic particles. Let's start with electrons. Electrons are said to carry a negative charge. So E for electron, this is just to show that they carry a negative charge. And hence, you'll hear it is said that electrons are negatively charged. And they have a charge of about minus 1.6 multiplied by 10 raised to the power of minus 19 coulombs. So for people that have already done electrostatics, for most people it was during term 1 in grade 10, this number looks very familiar. So the charge on an electron is a negative minus or a negative or a minus 1.6 multiplied by 10 raised to the power of minus 19 coulombs. Now, what about the protons? The protons are said to be positively charged. So just threw a P with a positive there at the top to show that they carry a positive charge. And now, different from or opposite to electrons, these protons have a charge of positive 1.6 multiplied by 10 raised to the power of minus 19 coulombs. So realize that these values, the difference in charge is a sign, the minus and the positive. And again, the last thing I talked about was the neutrons. The neutrons are neutral. This tells us that they actually don't carry any charge, hence they have a charge of 0 coulombs. The number of protons in an atom determines its atomic number Z. So atomic number Z or Z is the number of protons in an atom. So every time we see the letter Z, we just know that tells us the number of protons in that atom. For an example, if you look at this copper atom, we would say that its atomic number is 29. And this tells us the number of protons in a typical copper atom. Let's look at a few examples. So if I said to you that a hydrogen atom has an atomic number Z of 1, how many protons would we find in a hydrogen atom? Think about it for a minute. So the atomic number for this hydrogen atom is 1. How many protons would it have? It would in fact have 1 proton, because the atomic number Z is equals to the number of protons. Hydrogen has an atomic number of 1, it means it has 1 proton. Let's say then I gave you a carbon atom and I said the atomic number Z of that carbon atom is 6, and I asked you to tell me how many protons does a carbon atom have. From what we've learned, we would know that it actually has 6 protons. Last, we can look at oxygen, an oxygen atom, and I said this oxygen atom has an atomic number Z of 8. How many protons does it have in its nucleus? It has 8 protons in its nucleus. So we'll see that the atomic number from 1, 2, 3, 4, 5, all the way to about 118 is always an integer. This is just an old periodic table, but typically this ranges from 1 to 118, and that atomic number tells us the number of protons in that atom, so the number of protons that you find at the nucleus of that atom. The number of protons and neutrons in the nucleus of an atom is called the atomic mass number, A. So this tells me that the atomic mass number A is equals to the number of protons and the number of neutrons in the nucleus of that atom. So if we had a hydrogen atom, which we have learned that its atomic number is Z equals to 1, or the number of protons of hydrogen is 1. And now I tell you that the atomic mass number of hydrogen is 1. And I'm asking you to tell me what is the number of neutrons in a hydrogen atom. I said to you the atomic mass number A equals to the number of protons plus the number of neutrons. We know the atomic mass number is 1. We know that the number of protons is 1. What then is the number of neutrons? N. You can already tell to find the number of neutrons, I'll just say A minus A, which is the atomic mass number, minus Z, which is the atomic number. So A minus Z will give me N. So it's going to be 1 minus 1, which will give me the number of neutrons. So what I've just said is that N will just be equals to A minus Z. N, the number of neutrons, is equals to A, the atomic mass number, minus Z, the atomic number. So for this instance, we'll have 1 minus 1. What is 1 minus 1? We know that 1 minus 1 is 0. So this tells me that, okay, hydrogen has 1 proton, but it has 0 neutrons in its nucleus. Let's take a look at carbon. Carbon has an atomic number of 6, or Z equals to 6, or the number of protons in carbon is 6. And I tell you that it has an atomic number of 12. How many neutrons does carbon have? We'll still use that formula, that the number of neutrons equals to the atomic mass number A minus the number of protons Z. So, well, how much is that? We have 12 minus 6. How much is 12 minus 6? So we know that carbon has 6 protons. 12 minus 6 is 6. So it will tell us that carbon actually also has 6 neutrons. The last example we can look at is oxygen. So we say that Z, or Z for oxygen, is 8. The number of protons is 8 in the nucleus of an oxygen atom. Its atomic mass number is 16. How much is the number of neutrons? To find the number of neutrons, we'll say N, which is the number of neutron, equals to the atomic mass number A of 16 minus the number of protons, which is 8. How much is 16 minus 8? So we had said earlier that the oxygen atom has 8 protons. 16 minus 8 will give us 8 neutrons. So this oxygen has 8 protons and 8 neutrons in its nucleus. The atomic number Z, the mass number A, can be represented using something called the standard notation. So in the standard notation, you have X, which tells us the chemical symbol of whatever atom you're trying to represent. A is the atomic mass number. Z is the number of protons. So the chemical symbol, the atomic mass number A, the atomic number Z. For an example, hydrogen has an atomic number Z of 1, an atomic mass number of 1. How would we write this in the standard notation? So we would write this and say, okay, where we see X, we just write H. That's the chemical symbol for hydrogen. The atomic mass number for hydrogen is 1, so we write it there as a superscript. And the atomic number for hydrogen is 1. We'll write it there as a subscript. We can do a similar thing for carbon as well, which has an atomic number of 6 and an atomic mass number of 12. So how do you think we will write that in standard notation? So we'll say, okay, carbon, atomic mass number of 12, we write it as a superscript, and an atomic number of 6, we write it as a subscript. Last but not least, we can also write oxygen in standard notation. Oxygen has an atomic number of 8, an atomic mass number of 16. So how would we write that? So we'll just draw the chemical symbol for oxygen, which is O, 16 as a superscript, 8 as a subscript.